Okay, so first we're going to talk about the alternating series test. Okay, and this is for alternating series. So what that means is, for example, if you have the sum of negative 1/2 to the n, all right, then that's going to go positive, negative, right? Because you put, well, n equals, let's see, n equals 0. Then that's going to go 1 plus negative 1/2 plus positive 1/4 plus negative 1/8. So it's alternating. All right. And in an alternating series, okay, then, I mean, I would do this one as a geometric. Oh, well, no, sorry, we're not doing this one as a geometric, though. I mean, this was just an example of what alternating means. Okay, so for the alternating series test, though, it's if the sum from n equals 1. So that's like you have a negative 1 to the nth and then an, and an is greater than 0, right? Because you don't want to mix up your negatives and positive stuff going on. But, okay, then and this is also 1. That also is an alternating, okay? Then the convergence for the following conditions are both met. So both must be true for convergence. 1. Well, it has to be the nth term test. That's the first thing, okay? So it still has to pass the nth term test, which is that the sequence goes to 0, right? So in other words, the limit as n goes to infinity of an equals 0, right? And then 2, an plus 1 is less than or equal to an. So in other words, the series is monotonic. Remember, the sequence, not the series. The sequence is monotonic, right? It's an. I don't know why I wrote it this way. I should write it the other way. That's how the book wrote it, but that's annoying. If you have an eraser, you should change it. It just makes more sense. This is the next one, so we read left to right. So this is the one that we're on, and the next one should be less than or equal to it. So monotonic, so it's non-increasing. You can't say decreasing because if they're equal, but non-increasing. Okay. So let's do some. Determine the convergence. 1. The sum from n equals 1 to infinity of n over negative 2 to the n minus 1. Negative 2 to the n minus 1. Okay. Well, first of all, we need to see, I always recommend just writing out a few of things. If you see like a negative number in there, then I want you to think alternating series. Okay. All right. So, I mean, just plug in a couple. N equals 1, you get 1 over 1, which is 1. Okay. 2, you get negative 2 to the 1. So you get 2 over negative 2 to the first, which is negative 2. And then 3, you get 3 over, what? Negative 2 squared, which is 4. There we go. So, and then the next one would be odd. Yeah, so it's definitely alternating. Okay. Okay, so it is alternating signs. Okay, so then now we're going to do the alternating series test, which is 1, does the limit as n goes to infinity of, okay, well, you got to pick this guy out. So this is going to be n over, well, you got to take the negative 1 out. So then it's 2 to the n minus 1, right? Does that go to 0? Well, that's definitely faster than that. Much faster. So yes, you can just write equals 0. But if you want to do a little bit of fancy footwork, then this is n over 2 to the n times 2 to the negative 1, right? So then that's going to be, now that's 2 to the negative 1, which would just bring that 2 up top. So that would be 2 limit as n goes to infinity of n over 2 to the n, in case you really wanted. And now exponential is obviously faster, like a way faster than linear, so it's definitely equal to 0. Okay, 2. We need to show a n is greater than or equal to a n plus 1. All right, now we've done this before, so you got to do some scratch work for it first, and then go back and write it. Okay, so what's a n? That is n over 2 to the n minus 1. And then, yeah, let me see. And then what is a n plus 1? So I'm just going to kind of put a line here. A n plus 1 is n plus 1 over 2 to the n plus 1 minus 1. Okay, so this is n over 2 to the negative 1 times 2 to the n. So that's 2n over 2 to the n. That looks like a negative sign. Okay, this side. This is n plus 1 over 2 to the n. Okay, now the denominators are the same, so really you're just comparing the numerators. So is 2n greater than or equal to, that's the question, n plus 1? Yeah, I mean, definitely. Take 1 and you get 2 equals 2. And n for, this should be for n greater than or equal to 1, right? Because our summation is for n greater than or equal to 1. So you plug in 1, and then now plug in 2, you get 4 to 2, to 3. Yeah, so that one. All right, so now you're ready. So then we're going to just show it by going backwards, right? So since 2n is greater than or equal to n plus 1 for all n greater than or equal to 1, then what? 2n over 2n, 2 to the n is greater than or equal to, there I am, n plus 1 over 2 to the n. Oops, sorry, I'm off screen, didn't realize that. My bad. Okay. Next sentence, and then what? Oh, and then now I can write that. Then 2n over 2 to the n equals n 2 to the negative 1, 2 to the n equals n over 2 to the n minus 1. Which is, that's a n. And then now do this one, n plus 1 over 2 to the n equals n plus 1 over 2 to the n plus 1 minus 1, which is a n plus 1. So a n is greater than or equal to a n plus 1 for n greater than or equal to 1. And then I'm going to cross this out and do that there. Just because I'm on their free response, I'm going to need to do that, which is looking like the whole exam's going to be free response. So we're definitely going to want to show our work. Okay. So that is the alternating series test. I'm going to do one more. I know they're long. I'm sorry. Well, like the process, me talking it out is long. I'm sorry about that. Okay. Okay, let's see, 2. There we go. The sum from n equals 1 to infinity of negative 1 to the n plus 1 over n. Okay. This is obviously alternating. Okay. So, but I'm just going to do the limit as n goes to infinity of n plus 1 over n does not equal 0. It equals 1. Okay. So, by the alternating series test, the series diverges. Okay. Let's do one more that converges. Okay. Oh, no, that's, yeah. So, okay. Let's do one more. The sum from n equals 1 to infinity of negative 1 to the n 1 over n factorial. Okay, definitely alternating. So alternating series test, 1. Limit as n goes to infinity of 1 over n factorial is 0. Okay, scratch work. I want to know, is a n less than or equal to a n plus 1? Okay. So a n is 1 over n factorial, and is that less than or equal to, no, greater than, sorry, it's supposed to be decreasing, right? 1 over n plus 1 factorial. I would say a big old duh. I mean, I don't even think you need to, that's just really obvious. This denominator, the numerators compare, they're the same, so you can just strictly compare the denominators. This one's obviously bigger than this one, therefore the ratio is smaller than this one. So I don't even think you need to, there was no scratch work. Okay, so a n equals to 1 over n factorial, which is greater than or equal to a n plus 1 equal to 1 over n plus 1 factorial is true. Okay, therefore, by alternating series test, the series converges for n greater than or equal to 1. Okay, that one was an easy one. All right, that is it for alternating series test.